After their incredible journey through the male and female reproductive tracts, sperm are now approaching their ultimate destination, and this is the secondary oocyte, or the egg, waiting in the expanded ampulla of the oviduct, also referred to as the uterine tube or fallopian tube. Of the millions that began the journey, only 100 or so sperm will arrive safely and compete for their chance at fertilisation. As sperm near the end of their journey in the oviduct, their focus changes from just finding the egg to preparing for the ultimate event, fertilisation. The preparations that sperm undergo are known as sperm activation or capacitation. These are the acquisition of the ability of a sperm to recognise and interact with the egg. The exact triggers for sperm activation are not fully understood, but they're known to involve environmental factors in the female reproductive tract. During sperm activation, or capacitation, the membranes over the sperm head become less stable and more fluid, which subsequently enables the release of enzymes during the acrosome reaction, and the sperm tails become capable of more frantic and forceful movements known as hypermotility. Once activated, sperm are equipped and ready for their meeting with the egg, but first they must navigate their way through the layers immediately surrounding and protecting it. The final step in the sperm's quest to meet the oocyte involve firstly penetrating the cumulus to reach the zona pellucida surrounding the oocyte, then binding to the zona, where membrane proteins in the sperm head bind to ZP3 receptors of the zona pellucida through a key and lock mechanism, which brings about the third stage, which is the acrosome reaction. This is where sperm membranes vesiculate. This means that pores form in the membrane, and enzymes are released from the sperm head to facilitate the fourth stage, which is zona pellucida penetration. Here, a combination of enzymatic digestion and thrusting of the sperm tail enables the sperm to pass through the zona pellucida to enter the perivitelline space, immediately surrounding the oocyte. Finally, the stage is set for fertilisation. Fertilisation begins with the physical contact between a sperm and the oocyte. This contact involves a region of the sperm head from which the plasma membrane has been removed in the acrosome reaction, binding to the oocyte plasma membrane in an event known as sperm-oocyte binding. Binding then triggers additional events involving the oocyte that prevent the participation of additional sperm in fertilisation, which is called polyspermy, and completes the fertilisation process. The stages of fertilisation are as follows. Firstly, the sperm are incorporated into the oocyte cytoplasm, or commonly called the ooplasm. Both the sperm head and tail are taken into the ooplasm. Secondly, after a single sperm has entered the oocyte, the egg depolarises. Depolarisation means that there is an increase in the level of free intracellular calcium within the oocyte. This causes a barrier to prevent multiple sperm entering the egg, and this is very important because polyspermy, as I've already mentioned earlier, would lead to a condition known as polyploidy, in which the zygote would have too much genetic information and is often not viable. The third stage is when you get reactivation of meiosis in the secondary oocyte and extrusion of the second polar body. In the fourth stage, decondensation of the sperm and oocyte nuclei form the male and female pronuclei. The fifth stage is syngamy, and this is where you get merging of the pronuclei and mixing of the male and female chromosomes. Fertilisation is now complete. The fertilised egg is a diploid zygote in readiness for the first mitotic cell division.